Hello everyone. In this question, it is asked that if S be the sum of all real values of m, for which the equation mx cube minus 9x square plus 12x minus 5 equal to 0 has two equal roots, then we have to find the value of the greatest integer function of S. Okay. So we are given a cubic equation mx cube minus 9x square plus 12x minus 5 equal to 0. Okay, so if I divide both sides by m, assuming that m is not 0, okay, this equation becomes x cube minus 9 upon m times x square plus 12 upon m times x minus 5 upon m. Okay, and I am assuming m is not 0, assuming m not equal to 0. All right, now it is given that this equation has roots. We are given that there are two equal roots, okay, and a cubic equation should have three roots. So let us assume the roots are alpha, and the distinct root, the defined root, be beta. Okay, so now we can use the sum of roots and product of roots relations. Okay, so the first relation, sum of roots, alpha plus beta, this is equal to minus of coefficient of x square upon coefficient of x cube, right? So this becomes minus of minus 9 upon m divided by 1. Okay, so this implies 2 alpha plus beta is equal to 9 upon m. Okay, let's say this is equation 1. Then we have the sum of product of roots taking 2 at a time. Okay, so we have alpha square plus alpha beta will be equal to the coefficient of x, the sign alternates, right? The coefficient of x upon the coefficient of x cube. So this becomes 12 upon m upon 1. So this becomes alpha square plus 2 alpha beta is equal to 12 upon m. Okay, let's say this is equation 2. And lastly, the product of all roots, which is alpha times beta. So this becomes alpha square beta will be equal to the negative of the constant term upon the coefficient of x cube, right? So this becomes negative of minus 5 upon m upon 1. So this implies alpha square beta is equal to 5 upon m, right? So these are the three equations we've got so far. Okay, and the roots are alpha and beta. Okay, so let us try to find the value of alpha beta in terms of m first. Okay, so taking equation 2 and 3 together, okay, we have alpha square plus twice alpha beta upon 12, alpha square plus twice alpha beta upon 12 will be equal to alpha square beta upon 5, because both of these values are equal to 1 upon m, right? You see, if I take 12 in the denominator here, this becomes 1 upon m. Similarly, in 3, if I take 5 to the denominator, this becomes 1 upon m, right? So I'm equating these two terms here. Okay, so let us see what we get here. I can take alpha common in the numerator here, so this becomes alpha times alpha plus twice beta upon 12 is equal to alpha square beta upon 5, right? So I am cancelling one alpha here since alpha is not equal to 0. This is because since alpha is a root of this equation, right? This original equation. So if I put the value of alpha in place of x here, we see the equation changes to this term becomes 0. Again, if I put alpha equal to 0 here, this becomes 0, this becomes 0, and we are left with minus 5 upon m equal to 0. Now, since m is assumed to be not 0, this is a non-zero term upon non-zero term, right? So this constant term cannot be equal to 0. Or you can place the value of alpha equal to 0 in the original equation also. You see minus 5 equal to 0. This term becomes 0, second term becomes 0, third term becomes 0. So this is a absurdity. Okay, so we can assume alpha is not 0, so we are cancelling alpha from both sides. So now this becomes 5 alpha plus 10 beta is equal to 12 alpha beta. Okay, so if I take beta common, okay, so if I take beta common or 2 beta common, I'm taking 10 beta to the other side. This becomes 6 alpha minus 5 is equal to 5 alpha, right? So I can take beta equal to 5 alpha upon, if this 2 goes inside the bracket, this becomes 12 alpha minus 10, right? I think everything is correct so far. Okay, so this is the value of beta here. Okay, now I have taken 2 and 3 here. Now let me try with 1 and 3. Okay, equation 1 and equation 3. So from 1 and 3, again 2 alpha plus beta upon 9, 2 alpha plus beta upon 9 will be equal to alpha square beta upon 5, as again both of these equations are equal to 1 upon m, right? If I take 9 in the denominator, this becomes 1 upon m again. Okay, so I am equating these two, and let us say this is equation 4. Okay, this value of beta in terms of alpha. So again, if I cross multiply both sides, this becomes 10 alpha plus 5, this becomes 5 beta, right? So instead of beta, I am using this expression of alpha. 12 alpha minus 10 is equal to 9 alpha square times 5 alpha upon 12 alpha minus 10. Okay, I have used this equation, this value of beta in this equation after cross multiplication. Okay, so this now becomes 10 alpha plus, this becomes 25 alpha upon 12 alpha minus 10 is equal to, this becomes 45 alpha square times alpha becomes alpha cube. Okay, 45 alpha cube upon 12 alpha minus 10. Okay, so if I take LCM on the left hand side, this becomes 10 alpha times 12 alpha becomes 120 alpha square, minus 10 alpha times 10 becomes minus 100 alpha plus 25 alpha upon 12 alpha minus 10 is equal to 45 alpha cube upon 12 alpha minus 10. Okay, so I am cancelling these two terms, assuming that alpha is not equal to 10 upon 12. Okay, so if this is true, we have the equation 45 alpha cube, and if I take this term to the other side, this becomes minus 120 alpha square, and this becomes minus 75 alpha. So if this goes to the other side, this becomes plus 75 alpha is equal to 0. Okay, so I am dividing both sides by what can be taken common. 15 alpha can be taken common. Okay, so this becomes, on dividing by 15 alpha, this becomes 3 alpha square, and this becomes 8 alpha, and this becomes 5, I believe. Okay, dividing by 15 alpha. Okay, so we have 3 alpha square minus 8 alpha plus 5 equal to 0. So this can be factorized as alpha minus 1 times 3 alpha minus 5. 3 alpha square minus 3 alpha minus 5 alpha 8 alpha plus 5. Okay, so we get two values of alpha now. So we get alpha equal to 1, or we get alpha equal to 5 upon 3. Okay, so from here we get the value of beta to be 5 alpha upon 12 alpha minus 10, right? So this becomes 5 upon 12 minus 10 is 2. Okay, similarly here we get value of beta to be 5 times 5 upon 3 upon 12 times 5 upon 3 minus 10. Okay, so in the numerator this becomes 25 upon 3, and in the denominator this is 12 times 5 is 60, right? 60 by 3 is 20, 20 minus 10 is 10. So value of beta now becomes 25 upon 30, which is nothing but 5 upon 6. Okay, so these are the two values of alpha and beta we have got so far. Now let us find the value of m, because we have to find the value of s, and s is, for s we need to find the values of m. Okay, so let us use this equation. Okay, of these three equations I think this is the easiest to compute. Okay, so from here let us find the value of m in either case. So m is equal to alpha square beta is equal to 5 upon m. So m will be equal to 5 upon alpha square beta. 5 upon alpha square beta, right? In this case also this is going to be 5 upon alpha square beta, right? So we get the value of m in the first case. Let's say this is m1. Okay, m1, and this is m2. Okay, alpha is 1 and beta in the first case was 5 upon 2, I believe. Yes, 5 upon 2. Okay, so this gives us this 5 and this 5 will cancel each other, and this 2 will go to the numerator, so this becomes 2. And in this case m2, 5 upon, this is 5 upon 3 whole square times 5 upon 6. Okay, so 3 square is 9, so this 9 goes to the numerator, 6 goes to the numerator, and 5 is in the numerator, this original 5, and we have 5 cube in the denominator, 5 cube. So we can cancel this, this becomes 5 square. So we get the value 54 upon 5 square is 25. Okay, so we get the two values of m. Now s is equal to m1 plus m2. Okay, so first value is 2, the other value is 54 upon 25. Okay, so this is 2 and this is 50 upon 25 is 2, right? So this is more than that, so this is, let's say, 2 point something pq, whatever. I am not doing the division here. Okay, so this is equal to 4 point pq something. Okay, now we were required to find the greatest integer value of s. Okay, so the greatest integer value will be the greatest integer value of 4 point something, right? So this is equal to 4, so this is the required final answer. Okay, okay, this is the required final answer. There were some computation required here in this question, but overall this is a very easy sum. Okay, no hard formulas were used here, only some algebraic manipulation and a bit of calculation. Okay, so this is the required answer. Okay, no need to do this division. If you want you can do it, but it is enough if you keep it like this. Okay, so if there is any doubt in any step you can highlight in the comments. Okay, and otherwise this is finished, and thank you for watching.